Hi, I would like to do a demo of the point data flow in a Zephyr application. So this uses the Simple IoT point data type, and it's how we move data around between distributed IoT systems. And it's also how we move data between our applications and a web application. So that's what I want to demonstrate today, how we can make this easy. So we have Zephyr running on an ESP32. This is the console. And we're serving up a web application from this device, and here it is. If we want to change a setting, we can do that. If we look at the back end, we can see that the setting was received and stored in non-volatile storage. So, how does this all work? Well, this web application is written in Elm, which is a functional compiled language, and it runs as a single page application, so no rendering happens on the back end. The back end is purely an API, and the front end does all the web HTML rendering, updates, and all that stuff. So we can look at the data that's flowing back and forth. And so for the back end simply provides an array of points. And each point has a type, a key, a data type, and a data field. So you can see the handful of points, and then this web application renders these points to show the data. So it's kind of dynamic. You know, in Elm we can do a lot of neat things like this. If we make changes, we can accumulate those changes or discard them. And then whenever we hit save, it takes a set of accumulated point changes, sends those to the back end, and then the back end sees those points. So what if we would like to make add a new feature to our UI? Let's call this a PID gain. So we want to switch into development mode for the web application, and we're using ElmLand, so we'll start the ElmLand server. And then we'll open up that. And what this does is it allows us to see real-time changes of our web application as we're coding it. We don't have to reflash the Zephyr device. This runs all outside Zephyr, and then we just proxy the requests back to the Zephyr device. So let's make a change. Here's our code. Let's add a field for PID gain. So here you can see different fields. We have a description field, a static IP field, a PID gain field, and then if the static IP is selected, we show some more fields. So this is all that's required to add a new setting. So when we save this, if you'll watch the web UI, you'll see this PID gain shows up right away. So we can set this to whatever we want, but if we go look at the back end, we'll see that nothing's really happening. This v1 handler is actually in the web server code, so nothing's happening with this yet. So let's change that. Let's go back to our main module, and let's listen to the. So we're using ZBus to move data, these points, through the system. And let's use our point channel. We're using a common point channel, and we listen to the point channel. And if a point of type PID gain comes in, then we're going to log a message. Normally we would do something with this. So let's compile and flash this new code. Okay, now we're running the new code, and let's go back to our web UI. Let's set our PI gain to 7.9. Now we'll notice that we see a message from the main thread that says do something with PID gain 7.9. So that's good. But there's one problem yet. If we reboot the system, which I'll just do right now. Okay, system is rebooted. And we'll notice the PID gain got blanked out because we haven't saved it. So let's fix that. Let's go back to our main module. And the way we set this up, we have an NVS service that basically listens for points, and we send this NVS service a table of points that we want persisted in non-volatile storage, NVS. And if the point is in this table, we persist it. If not, we don't. So let's define a point type PID gain, and we're going to put this in our NVS table. And again, we're going to build and reflash their code. Okay, we're back up and running with the NVS code enabled. So now let's set our PID gain to 1.2. Now if we look at the Zephyr console, we see main got the point, and we also stored it in NVS. So now when we reboot, we should have this set on boot up. Okay, we're back up again, and we'll notice on startup the main thread said do something with PID gain. And here we never actually set the PID gain from the web UI, but what happened is on startup, the NVS service, it looks at our table of points in NVS, and it broadcasts all those points on the point channel. So on startup, we broadcast all the points we've saved, and that's how we kind of hydrate the system with the points that are persisted. And likewise, if we go look at the web UI, it shows the point. So the last thing I'd like to demonstrate is how we can set points from any place. So if you type help, you'll notice there's a point command. We can set point, PID gain, 0, float, 7.3. And let's watch the web UI as we do this. So here we sent a point, we notice it got stored, and also the web UI picked it up. So in this system, points can flow in any direction, and that's very useful because you might want to set a config setting from a command line, you might want to set it from a web UI, you might want to set it from a Bluetooth app, a connection, you might want to set it from an upstream gateway or cloud instance. And this granular, putting everything in a granular point allows us the granularity to move data around in any direction, and it gives us a lot of flexibility. That's it. Thanks.